video, we are going to look at some key features of the graph of cosine theta. Very similarly to what we did with sine theta, we are going to look at what happens as you move around the unit circle and look at how the coordinates are affected by cosine of theta. So if you remember, cosine goes with the x-axis. So as we are looking at our coordinates of the various points, let me put those on here. We are going to focus on the x value of those coordinates. So x value of this one, well, I went 1 over from the origin, so this one is a 1. This one, I only went up. I didn't go over at all, so this one's a 0. This one, I went to the left, so that's -1. And then again with this one, just like the one up here, I only went down. I didn't go over at all, so that one's going to be a 0 as well. So when I come over to my x-axis to put on those points, at 0, this time I'm going to start up here at 1. And as I move around the unit circle in a counterclockwise manner, as I go positive, I'm going to go from 0 to pi over 2. Put a dot on pi over 2. And then from pi over 2, I'm going to go around to pi, which is going to move my y value down here to -1. I know it's the x value of this point, but it's the y value of the graph. So 3 pi over 2, I'm moving down here, its x value is 0. So when I graph cosine, the value I'm going to get there is 0. And then 2 pi, as I move around back over here, I'm back to 1. Let me put a dot there. Okay, so now I'm going to connect those dots. And if I start right here at the 1, in this case, I'm going to go down, down again, and then come back up. So just like we talked about with sine theta, I could potentially split this curve into 4 pieces in between each pair of points. So here's 1, here's 1, here's 1, and here's 1. And again, just like with sine, those correspond to my quadrants that I have over here. When I'm in the first quadrant, you can see that cosine is positive and it's going from 1 to 0. That x value is shrinking as you go from the x-axis over to the y-axis. So there's quadrant 1. In quadrant 2, you can see that all my x values are negative and they are moving from 0 to -1. So here's quadrant 2. In quadrant 3, my cosine values, those x coordinates, are still negative, but I'm moving from -1 around to 0, just like I'm doing right here in the third quadrant. And then in the fourth quadrant, as I am moving from 0 up to +1, cosine is back to being positive again. I'm starting at 0 and I'm moving up to +1, just like I'm doing right here. So this particular portion of the cosine curve is one trip around the unit circle. And then just like we said with sine, it's periodic. And so if I wanted to go around and around and around the unit circle again, and again, and again, I could do that. I would just continue my curve in that same way. And it's going to go down, down, up, up, down, down, up, up. And it would just keep going like that forever and ever as I move to the right. Okay, so let's see what happens as I move to the left. You're going to find that just like what we talked about last time, the same thing is going to be true. If it is going to continuously be repeating, it ought to have the same repeating pattern both on the left and on the right. So let me put some dots on here. These are the points we're going to be considering, just the ones for the quadrantal angles. And as I move around the circle, you can see that I'm going to start here at 1. All right, now this time I'm going to move clockwise. This time I'm going to move negative around the circle. So as I go from 1, I'm going over here to 0, and that's in the fourth quadrant. Here in the third quadrant, I'm going to go from 0 up to -1, right? And my cosine values here are all negative because the x-axis is negative. Here in the second quadrant, I'm going to move from -1 to 0. All my x values are going to be negative, but now I'm going to be moving towards 0. And then back to the first quadrant, I'm going to go from 0 to 1, and my values are going to be positive. Okay, so let's put the dots over here on our curve to represent that. So we started at 0 and we were at 1. And then when we went in a negative manner, we moved down to 0 with negative pi over 2. Then down to negative 1 here on negative pi. Back up to 0 on negative 3 pi over 2. And then I went to positive 1 over here on 2 pi. So if I connect the dots, just like what we did before, start here at 1 and connect down, down, up, up. And you can see I get the same curve. I'm just drawing it backwards. I'm just starting backwards like this because I'm going around the unit circle negative. And again, if I put my quadrant values on there, this is quadrant 4, this is quadrant 3, quadrant 2, and quadrant 1. So every value in here corresponds to every value that I have in here. And cosine, again, is the x values of these points, but then when I go to graph it over here, the cosine of theta is what I'm graphing. Theta would be like my y values. That's why I've got radian measures on the x-axis, and the answers that I get, which would be the coordinates from here, are going on my y-axis. So it's a little bit confusing if you think about the x coordinates from over here are matching with the y coordinates from over here. But there's 2 revolutions of the cosine curve. Okay, so I asked Desmos to draw me a nice curve, and you can see that I added arrows on both ends right there because it's going to go on and on forever. If I were to go around and around the unit circle in a positive way, or if I were to go around and around the unit circle in a negative way, this shape would just continuously repeat. So we said that this means it's going on and on forever to the left. And this one over here means it's going on and on forever to the right. So then what will my domain be? What means that it goes on and on forever to the left and on forever to the right? Well, that's going to be negative infinity to positive infinity, or I can use my all real numbers symbol. Okay, now range. Range is bottom to top. So what is the lowest that this graph goes? The lowest y value, because remember range goes with y, the lowest y value I'm going to have is negative 1. The highest y value that I'm going to have up here is positive 1. Okay, now should I put parentheses or brackets on that? Well, I'm going to need brackets because both negative 1 and positive 1 are included, right? You can see it actually reaches negative 1 right there at that dot. It actually reaches positive 1 right there at that dot. So because the graph actually touches those points, I want them to be included. So I'm going to put square brackets. I put parentheses when it's not included. And remember that infinity and negative infinity are never included because we can never actually quite reach them. Okay, so let's talk about period, just like we did with sine. The definition is the same. Any one full pattern in a repeating graph is called a cycle. So you can see that I zoomed out even further here on cosine, and I have several cycles. So here's one. This is the one we drew just a minute ago, starting at 1, going down to negative 1, and coming back to 1 again. But you can see I have that going again and again and again. So I have several cycles on both the left and the right. Right over here, you can see I have 1 full cycle, 2 full cycle, 3 full cycles on the left. And the length of the interval over which the cycle occurs is called the period. So this is the same period as what we had for sine. It's starting here at 0, and it continues to here at 2 pi. You can see I've got those values right there for you, 0 and 2 pi. And so the length of that interval is 2 pi. It wouldn't matter which one I chose. If I went from this one to this one, that length is still 2 pi. This length is also 2 pi. This length is also 2 pi. It doesn't matter. It's the same length. That interval is the same all the way across. So my period for cosine is going to be 2 pi, just like my period for sine. Okay, how about amplitude? Amplitude, you remember, is the distance from the midline, which in this particular graph is the x-axis. And we measure from the midline either to the top or we measure from the midline to the bottom. But it doesn't matter whether you do this measurement or whether you do this measurement, either way, you're going to end up with a measurement of 1. I went positive 1 this way. I went negative 1 this way, but that means that distance is a positive 1. The distance in between 0 and negative 1 is a positive 1 unit. So distance here is 1, distance here is 1, therefore my amplitude is 1 because cosine theta goes up and down 1 unit from the x-axis. Okay, so look back at this one that we had up here just a minute ago, the one that was 1 cycle on the left and 1 cycle on the right. Look at cosine, which you guys can see cosine. I'll trace over 1 cycle right here. Now I want to change colors and I want to trace over a slightly different cycle. What do you see right there? Well, that's the sine curve. The cosine curve and the sine curve are essentially identical to each other. It's just that one of them is scooted pi over 2 away from the other one. If I take sine and I scoot it pi over 2, I'm going to end up with cosine. If I take cosine and I scoot it pi over 2 in the opposite direction, I'm going to end up with sine. So sine and cosine have all the same features. It's just that they're in slightly different positions on the x-axis because of how the coordinates go as we move around the unit circle.